I think I am live. So in this class, we will be discussing about carrier screening in spinal muscular atrophy. So first of all, why carrier screening is required in spinal muscular atrophy? This is because SMA, that is spinal muscular atrophy, is the second most common fatal autosomal recessive disorder after cystic fibrosis. The prevalence is around 1 in 10,000. The most important fact is carrier frequency. Look at that figure. The carrier frequency of 1 in 40 to 1 in 60. This is same across almost all ethnicities and populations. This means that among apparently healthy looking individuals, 1 in 50 is a carrier for spinal muscular atrophy. So you can easily understand that then the chance of two individuals who has spinal muscular atrophy carrier status and producing children is high. So we need to screen for spinal muscular atrophy. Also, another problem is that even though we have certain genetic therapeutics for spinal muscular atrophy like Zolgensma, Itvisma, Nusinersen, Risdiplam, the cost is exorbitant. So at this point of time, the best prevention is by primary prevention. Look at the carrier frequency across ethnicities. It's roughly 1 in 50 across all populations. So this is a pan-world problem and it is not restricted to a particular population or a particular country. Now coming to how to do SMA carrier screening. The best approach is to do SMA MLPA of both partners. It will cost anywhere between 2,000 to 5,000 per person depending upon the labs. If both partners have only one functional SMN gene, that means they are carriers, then 25% chance of having an affected offspring. Now coming to limitations of carrier screening. Not everything is foolproof. This is because 2% cases are due to de novo mutations. If you look at the spinal muscular atrophy gene architecture and the nearby genes, multiple repeat sequence across that region, so the chance of unequal crossovers and recombination events are high. So this results in high de novo mutation rate. So even if the out of 100 SMA patients, two kids won't be having two affected parents. So 2% causes are due to de novo mutations. And there is a phenomenon called silent carrier. I will explain that in detail. And 2 to 5% of carriers have sequence variants and not deletions. We know that the pathogenic mechanism of SMA is mainly by deletions of SMN1 gene. However, there can be single nucleotide mutations as well. So this will be missed in MLPA-based screening. Coming to silent carrier status. So in any case of, for the matter, any disease, we know there are two copies of a gene. One copy will be in one chromosome and the second copy will be in the homologous chromosome. However, there is some difference in spinal muscular atrophy. If you look at this configuration, you can see that there are two chromosomes. In each chromosome, there is one functional SMN1 gene. Perfect. So he or she is not a carrier. So this configuration is known as 1+1 configuration. Look at this. This is a classical carrier. So his or her one copy of SMN1 is deleted. So he or she has one functional copy. So he is a carrier. He or she is a carrier. Now coming to this interesting configuration. Here, if we do an MLP in this third case, we will get what? Two copies of SMN1. However, both the copies are in same chromosome. The second chromosome does not have even a single copy. Why it happens? Because there are multiple gene duplication events due to which one SMN1 can give rise to another SMN1 copy. So what will happen? Even though this person has two SMN1 copies, one of the chromosome is empty regarding SMN1. So he is a carrier. And this is another configuration in which there are two SMN1 copies dictated in MLP. However, one copy is damaged due to some single nucleotide variants. That means single nucleotide mutation. So in MLPA, we cannot dictate single nucleotide mutations. We will dictate only deletions or duplications. So this person will also be reported as a person having two SMN1 genes. However, one gene is damaged, which is denoted in red color. The functional one is denoted in orange color. So the bottom two configurations are known as silent carriers. In MLPA, there will be 2 copies of SMN1 gene. However, in functionally, there is only 1 copy of chromosome with functional SMN1 gene. Now, how to detect this? Frank answer, really difficult. So scientists have found out certain ways. So there are certain single nucleotide variants in the one in the intronic region between exon 7 and exon 8, and one in exon 8. So these two variants, if detected, then there is a high risk of the person being a silent carrier, that is 2+0 configuration. Why so? Because these variants usually co-occur. However, individuals with only one of the 2 variants have been identified. So along with MLPA, we need to test for these 2 variants as well. However, we usually don't do that because the kits are not easily available. So we usually go for a single MLPA. And coming to risk assessment, if we have the facility of testing for these 2 variants as well. So coming to the example of an Asian population individual. The carrier frequency, we know 1 in 50. We already discussed that in the second slide. If we test that person and the result comes out to be 2 copies of SMN1, then what will happen? The risk decreases to 1 in 719. Why not 0? Because there is a chance of silent carrier. There is another chance that the damaging mechanism of one gene may not be a deletion. It can be a single nucleotide mutation. In that case also, he or she will remain as a carrier. Suppose there are 3 copies, which is quite possible in spinal muscular atrophy because of gene duplication events. Then the risk of being a carrier decreases further to 1 in 5,100. If we test for this 2 variants which are associated with silent carrier configuration, and if any one of the variant is positive, then the risk of being a silent carrier increases by increases to 1 in 50, which is very high, which is almost similar to population carrier frequency. So the ideal way is MLPA with the sequence variant testing for these 2 variants. However, it is not really available across all the labs in India. So we usually go for only MLPA, plain MLPA. So risk calculation for Asians, baseline population risk is 1 in 50. If we get 3 copies of SMN1, carrier frequency, carrier being a carrier risk is 1 in 5,000. 2 copies and we don't know the variant status, 1 in 719. 2 copies and we tested for variants, and if the variant status is negative, the risk is 1 in 700. If 2 copies are present and variant status is positive, then high risk of being a carrier for SMA. So that's it. If you have any doubt, please you can email me. Find me in various social media platforms using the handle @tinyphysician. Thank you.